Hi everyone. So in this video, we'll be solving aptitude questions from GATE 2023. So starting off with the first question, it's a fill in the blanks question. So the question says, he did not manage to fix the car himself, so he dashed in the garage. So the first option is got it fixed. So let's just assume that this is the answer. How would the statement go then? He did not manage to fix the car himself, so he got it fixed in the garage. It seems correct. The second option, he did not manage to fix the car himself, so he getting it fixed seems, incomplete. If it would have been, so he is getting it fixed would have been the correct answer. But again, that's not the case. So he gets fixed, he's not getting himself fixed. So again, these two statement talks about where he is himself getting it fixed. He's not getting the car fixed, but he's getting himself fixed. So again, the first is the correct answer. Second question is about similarity. Planting is to seed. Similarly, raising is to what? The answer would be child. I hope this does not require an explanation here. Okay, the third question. So let's read the question. A certain country has 504 universities and 25951 colleges. These are categorized into grade 1, 2, and 3 as shown in the given pie chart. Fine. What's the question? What is the percentage? What is the percentage correct to one decimal of higher education institutes, both college and universities that fall under grade 2? So what does this question mean is they have been asking for grade 3 how many universities and colleges are included. Okay, the addition of both. So for universities in grade 3 I have 7%. Okay, 7% of total universities, which is 504. And for colleges, grade 3 colleges, I have 23% of total colleges. How many total colleges? 25951, right? So, what is 7%? 35.28. And what is 23% of this? 5968.73. So, final, the answer is supposed to be an addition of both. So, it's 6004.01. So, if you see the question properly, they have asked what is the percentage and not the number exactly. Okay, the percentage of the total. So, they've asked the percentage 6004.01 of the total universities plus colleges into 100%. So, this one would be around 22.69 percentage. So you see in the question they have also mentioned correct to one decimal place. So I would be rounding it off to one decimal. 22.70% is the correct answer. Hence option A. I hope this is clear to everyone. Moving ahead to the next question. Question number 4. So the question says the minute hand and second hand of a clock crosses each other dash times, as in they want the number of times. So how many times would the minute hand and the second hand, minute and the second hand, cross each other? So we know that a minute hand and a second hand would cross each other in a minute once. So basically in 1 minute once it will cross, right? So, how many minutes are there in between 9:45 and 9:15? From 9:15 a.m. to 9:45 a.m. there are 30 minutes, right? So, in 30 minutes, it will cross 30 times. Hence, answer number A. Clear? So, the next question, question number 5. Uh, the symbols, these are the symbols, are to be filled one in each row. Okay. Each box, the symbols, these are the symbols, are to be filled one in each box as shown below. The rules for filling in the four symbols are as follows. Fine. Each row and every column must contain each of the four symbols. Okay. So this means that each row should have unique symbol. Okay, there should not be any repetition. Similarly, this also should not have what? A repetition. There should be unique symbols to both. Second rule is every 2 by 2 square, as in this box, must contain each of the four symbols. Again, there should not be any repetition of the symbols. For example, if there is a triangle here, there cannot be another triangle. All the four symbols have to be there, and there could not be a repetition. Okay, so let's start solving. So I'll start from this side. Okay, so this particular box is complete. Fine. I'll move ahead to the next box, to this box. So I see that in this line, 1, 2, and 3 are filled. 1 is left. What was the rule? That every row and every column must contain each of the four symbols. So 3 are there. Which one is left? A square. Fine. So this one's filled. Now, if I look into this 2 by 2 box, what was the rule? All the four internal squares must have each of the symbols and there should not be any repetition. So I have this. The one left is this. Okay? So another, this and this boxes are filled. Next, the final answer is to find what would be in place of this question mark. So to make it easier, what I'll do is I'll try to find what would come in this box here. Okay? So if I look in this line, I have a square, I have this symbol, I have this symbol. What is left? This. Done? Clear? Now, if you see in this place, what are the two things that can be possible? I already have a triangle and a circle. It's either this or a square. Now the catch here is this symbol won't come. Why? Because in this line, I already have this here. Hence, this square is going to come. And hence, here I'll have this. Okay? So, our answer that in place of this will have this symbol. Hence, answer is B. Clear? Next question. So, this is a passage question. Let's just read it out. In a recently held parent-teacher meeting, the teachers had very few complaints about Ravi. Okay. After all, Ravi was a hardworking and kind student. This is a trait about Ravi. Incidentally, almost all of Ravi's friends at school were hardworking and kind too. Okay, almost all of his friends. Fine. But the teachers drew attention to Ravi's complete lack of interest in sports. The teachers believed that, along with some of his friends who showed similar disinterest, some of his friends, Ravi needed to engage in some sports for his overall development. Okay. Based only on the information provided above, which of the following statements can be logically inferred with certainty? First statement is all of Ravi's friends are hardworking and kind. So the question stated that almost all, but they didn't say all. So this is not correct. No one who is not a friend of Ravi is hardworking. This is also not mentioned. None of Ravi's friends are interested in sports. It's not said because already we know that most of them are hardworking, and the ones who are hardworking, they are not interested in sport. So this is also gone. So our answer would be D. Okay. Next question is about inequality. So the question says p square minus 4q is smaller than 4. This is the first equation. And the second equation states 3p plus 2q is smaller than 6. So there is this one statement which mentions that where p and q are positive integers. So we know that on this side we have positive numbers, on this side we have negative numbers. So these are known as negative integers and these are known as positive integers. 0 is neither positive nor negative. Fine. So the smallest integer that I can think of for both p and q, let's assume let p and q be 1. It cannot be 0, like we cannot have this combination 0 and 0 or 0 and 1 or right. So what would be our first case is where p and q are both 1. So this is going to be a trial and error question, right? So let's try to fit in this value in the equation. So let's see whether it satisfies the equation or not. The first equation, if 1 minus 4q, it's going to be 4. Whether this is correct or not. So minus 3 is definitely smaller than 4. It satisfied the first equation. Whether the same satisfied the second equations or not, let's see. 3p plus 2q smaller than 6. 3 plus 2, 5 is smaller than 6. Hence, this is a valid case. This value is approved. Let's take another case. If we have P1 and Q2, is it again going to satisfy both the equation? Let's see. In the first equation, P square minus 4Q, P is 1, but Q would be 8, right? So minus 7, 4. This is valid, right? This is fair. Second equation, 3p plus 2q, 6. 3 plus 2 to the 4. So 7 is not smaller than 6. Hence, this did not satisfy. Hence, we can say that this is not correct. So if you want to try the alternative as well, like if we assume case 3, P2 and Q1, let's see. 4 minus 4, it is smaller than 4. This is valid. for the second equation, 3 2s are 6 plus 2, not valid. So after doing all of this trial and error, we found that the only valid values for both P and Q, where they are satisfying the statement that they are both positive integers, is this, where P and Q are both 1. Hence, the final value for P plus Q would be 1 plus 1, that is 2. Clear? Okay. So next question is about the sequencing of the statements. So I think this would be an easy one. I just write the answer. It's number C. So yeah, if you have any doubt with this, you can write down the doubt in the comment section. We'll move ahead with the next question. So this is a nice question. Question number 9. So the question says, how many pairs of sets ST are possible among the subsets? 1, 2, 3, 4, 5, 6. Okay. That satisfy the condition that S is a subset of T. So S is a subset. Like if I assume that this is my T and this is S, right? So what would be the pair? How many number of pairs are possible where I can say that S is a subset of T and these are the numbers that I have. So there can be numerous, possibilities. So let's just start with one. For example, if I have 1, 2, 3, 4, 5, and 6. Okay, I'll just write them. So there can be chances where I have all my 6 numbers in set T, as in inside of T, 1, 2, 3, 4, 5, and 6, and none in S. So this would mean that out of 6, there are 0 in S. Hmm? Similarly, if I erase this once, yeah, and I say that out of those 6 numbers, 1, 2, 3, 4, 5, 6, any one of these are to be here. Any one. It can be 1, it can be 2, it can be 3, it can be any of the 6 numbers. So 6C1, out of 6, 1 is chosen. Similarly, 6C2, any 2 can be chosen. Hence, we'll have this till 6C6, where in this case, all the 6 numbers are present inside this, inside S, and S is a subset of T. Okay, let's write down this thoda systematically so that we understand what is going on. So how many numbers would be present in T? How many would be present in S? And what is the selection criteria? So if I select 0 out of 6 numbers to be present in S, it would be 6C0. Huh? If I select 1, it's going to be 6C1, right? If I say that 2 numbers are going to be selected, 6C2, 6C3, 6C4, 6C5, 6C6. All the possibilities I have written it down. And just write down this thoda properly. This is all in T, none in S. And this one is all in S, none in T. And these cases are some in T, some in S. Okay. So I would want to break this down. So do you know how to break these? So this one is going to be value 1, right? Because 6 divided by 0, 1. Now 6C1, 6, and this one 1. So hence 6. 6C2 would be 6 into 5 divided by 2, 15. 6C3, 6 into 5 into 4 divided by 3 into 2. So are you able to understand what I'm doing this? So if a number says 6C1, for example, this means that 6 is going to start and end at just the first number and the second one. Okay? If it's 6C2, what's going to happen is 6 will start and end at the second number in a decreasing order. Okay? 6 into 5. And the lower digit is going to continue till 1. Okay? Hence 15. 6C3 similarly will end at third number 6 into 5 into 4 and 3 will continue until 1. Okay? So how much would this be? Calculate karo. Try to solve for all the rest of the numbers. Okay? Pause the video and solve it and then check whether we are going on the same page or not. Okay? So 6, 3 is done. Then we have 6C4. So I'll start from 6 and end up till the fourth number. 6 into 5 into 4 into 3. And from 4 I'll start and end until 1. So this will give me how much? 15. Six C5 will give me 6 into 5 into 4 into 3 into 2 divided by 5 into 4 into 3 into 2 into 1. Okay, this is going to give me 6. And 6C6 would eventually be 1. Okay, I hope this one part is clear. So now, yeah. So in this first case, we said that 6 is in T and how many are there in S? None. So I'll be writing that 6 are in T, 0 in S. Similarly for 6C1, 1 is there in S and the rest here. This is going to continue. I wrote the opposite. Clear? Now why is this important? It's because, let's again take an example. If we have two numbers in a set, how many subsets are possible It can be 1, it can be 2, it can be 1 comma 2, or it can be 2 comma 1. So a total of 4 pair of 4, right? So this has one formula, 2 to the power n, where n is the number of elements here. So this also gives 4, right? So what is the final question that we have been asked for? How many pairs of sets? Okay. How many pairs of sets are possible for these elements? So our final equation would be a combination. So this particular question is very nice because why? Because it's a combination of permutation, combination, and sets. So what would be our final equation? It's going to be this multiplied by the number of sets, 2 to the power 0, again 6 into multiplied by 2 to the power 1, this into 2 to the power 2, this into 3 to the power 2 to the power 3. Okay. Similarly for the rest of them. So after you do this, you'll get 729 as your answer. Is it clear? What we did is the first part of the question, we tried to see how many, you know, combinations can be made to find the number of sets, okay, which satisfies that S is a subset of T. And then after we found out the number of, combinations that can be made to satisfy this particular statement, how many sets are possible then in all the cases that we try to do? Okay, after doing that, we submitted all of them and then we found that a total of 729 pairs of sets can be made. Clear? All right. Next question says that an opaque pyramid, as shown in the figure, with a square base and isosceles faces, is suspended in the path of a parallel beam of light, such that its shadow is cast on a screen oriented perpendicular to the direction of light beam. So if I say that a light beam is here, the screen will be present here perpendicularly. Fine? Yeah. Hmm. The pyramid can be reoriented in any direction within the light beam. So the question does not restrict us that the light beam is going to be at this position itself. The light can be here, here, anywhere. The only condition is if the light beam is here, the screen has to be at the perpendicular line. Right? Okay. Under these conditions, which one of the shadows P, Q, R, and S is not possible? So let's assume few cases. Let the first case be where I am positioning my light beam here. One. I'm placing it here. Okay. Second, the under. Third can be from this side. Or let's write this here. Second was under. and third be from this side. Okay? Why? Because if I see the first option, this, if I'm looking from here, I'll see a shadow to first cast this and this. This will be casted. Hence, this is possible, right? Second, if I see, if I'm looking from here, okay, on the same 2D plane, I'll be able to see this shadow R, right? This is also possible. Now, if I see from under the base, like perpendicular, if it's under here somewhere, and it's imparting light like this, and I have my screen here, it's going to give me a square base, this one. So this is also possible. Now, if a shadow casted from here is going to be this, so it's going to be the same for all the four sides, right? Now, one face which is left is the top. Even if I cast a shadow from the top, it's going to be a square, right? Exactly at the top. So, Q is the shadow which is not going to be casted, right? So that's the correct answer. So, yeah, these were the questions from GATE 2023. And the most interesting ones that I found were question number 7 and question number 9, which were a little different from most of the questions that I have done till now. So, yeah, I would very much suggest everyone to go through questions which are under the topic permutation and combination because that can be included in most of the topics for aptitude. So, yes, that was all. Thank you.